here is the black orchid from from the Institute Technology of Kalimantan. They will be presenting soon.
Ini dia hapus ya mas? Iya.
So here is the team of Black Orchid from Institute Teknologi Kalimantan. I would like to introduce you to all our jury. The first one is Dr. Komarudin from UTM. Second one is Dr. Ellen, and the third one is Dr. Hari. And you ready to begin your presentation? To the judge, can we start the presentation? Okay, the given time will be 7 minutes of presentation, 8 minutes of question and answer. Okay, get it? You may start your presentation a bit now.
The time will count when
Yeah.
Do you know how to operate it? How to use it?
Pointing there. You must do pointing there.
Point to the laptop.
Yeah.
Well, good afternoon, judges. To be honest, Dr. Komarudin, to be honest, Dr. Elliot, to be honest, Dr. Hari. Before we talk or do our presentation, I'd like to tell you a little information about our team. First, my name is Marcos Menengkalit. And beside me there are Guru Sandika, Saktia, Abrono Hadi, and last one is Wing Briawan. We are a Kemenkap team from Kalimantan Institute of Technology, usually called ICECC. And this is our second time in this competition. This is the outline that we're going to discuss about. First is background, second power source, the third is staffing mechanism, fourth feature, and the last is economical aspect. First, the background. The energy demands will increase while the population growth also increase. This can cause the increase of energy demands. By the time the energy availability is dominant by fossil fuel such as gasoline, diesel, natural gas, etc., which are not enough to fulfill the people needs, and they can also cause global warming and environmental issues. And the other side, the vehicle contribute 60% pollution in this on the earth. If the pollution has to be controlled, the vehicle must be run by another method. There are various methods. One of them is to create a new type of chemical reaction to help the car move. And in our team, our car is use aluminum air battery. Aluminum air battery, yes, aluminum and oxygen act as the anode and cathode, respectively, in the car. While the oxygen itself reduced in the battery, the activated carbon is used as the absorbent to capture the oxygen, to create the reaction. And this is the power source that we use. First is the electrodes. We use for the cathode is graphite plate. We made this by ourselves. And this, for the anode, we use aluminum plate. This is the pictures of a reactor that we use. It has 16 slots. It made from glass. Next. This is how we assemble the batteries. The graphite plate and the aluminum separate by the filter paper as the separator. And then for the electrolyte, we use 1% sodium hydroxide and 5% citric acid. And then we use 16 cells. Then we arrange it 4 series and 4 parallels, like that pictures. We assemble like that. And from this configuration, we could get 5 volts for the voltage and 2.8 ampere for the safety. For the carbon. Sorry. Next.
And now this is the basic concept of our stopping mechanism. Okay, our stopping mechanism use vitamin C block reaction with natural ingredients, so it's incrementally unified. Our reaction is like this. Basically, it's from this iodine plus vitamin C. It will produce iodide which is colorless. And then the second reaction is hydrogen peroxide and the iodide from the next reaction. It will produce iodine which is dark blue reaction, dark blue color. Okay, this is the basic concept is chemical. This is the solution that we need. We need solution A and solution B. Yes, like this. We need hydrogen peroxide. In this reaction, we vary the hydrogen peroxide concentration, and then we use for our solution. And then this is the solution B. We use povidone iodine, which contain 10% of iodine, and then we use lemon water.
And the next is the stopping mechanism part. And our car needs a light to make the cars constantly move. As Ellie said, the tendency block reaction turns the solution to be dark blue, and it blocks the sensor and the lights, and it goes to the circuit, and the circuit goes to the dynamo, and it makes the car gradually stop. So that's the brief explanation of the stopping mechanism. So that's next.
Yeah, next is the car user. In this car, we have 10 main components. First one is safety reactor right here, and number 2 is reactor inside the safety reactor. Number 3 and 4 is chassis made from slotted angel and composite plastic. Number 5 is wheel. We use 4 wheel in bottom. And number 6 and 7, we use single gearbox and dynamo in bottom. And number 8 is electrical system we put in the car. Number 9 is stopping reactor we put in this part. And number 10 is steering. We use it.
Okay. Unfortunately, the time is up. Now we will proceed to the question and answer session. To the judges, you may ask your question.
This is the problem we have. All right. So welcome the Kalimantan team. All right. So first of all, so this is your first time, or second time?
Second time.
Second time. So you have the last name
Yes.
and the same car, or this is different car?
We designed a different car.
Different
for
car.
us.
All right. So I do believe that if one of you basically in the last university team,
Yeah.
it's not of is one of you already basically in the previous year in the last team.
There are 3 of us.
Basically in the last
Yes,
team.
in this
Last
year.
team.
Yes.
All right. So you have the new one. Okay. All right. So you have experience last year basically that you know what basically your the what we call it the drawback or something which is wrong with your car, and hopefully that you have improved it for this year version. All right. And you're still using the same reaction, right? For the using the same with the last year, right?
We use the different power source, and for the stopping mechanism is different from the last year.
Alright, the power source and also the stopping mechanism, basically you already upgraded from the
Yes.
previous year's price. Alright, so you have this one, the body also I think looks powerful. Alright, compared to the previous one, right?
20 kilos.
Yeah, this one maybe
Yes.
2.2 kilos again. 4.3 kilos, alright, because of that
Solid
steel. Alright. And you already tried with a certain concentration of the chemicals, and you come up with 5 volts, 2.8 ampere with that 4 series of error oxidant. How far or how faster that this car can go with your specific condition of your fuel source?
0.16.
0.16. Because of the 4.8 kilo.
Yes.
And tomorrow you will have certain another 20% extra.
An additional 800 gram.
Yes.
Will be heavy.
Yes, that is the heavy sofa. Oh no, is it? I think it's the heavy stuff. And 0.6, yeah, you can operate it again. Try to stop at the target. Okay, because this year we don't play the ball.
Yes. The balls
like the previous years.
Yes.
Alright, because it goes straight and stop at that target. Alright, so you are already identified there is some limitation that you need to avoid for tomorrow's racing. For example, you need to make sure there is enough power. How to make sure that the clock will be stopped
Di sini juga.
at the time that you want, because yeah, the trial or not the trial, the one that you have developed or you have tried in Kalimantan will be different day, and tomorrow is racing, and the atmosphere will be different.
Banyak.
So how that basically this is
Nggak,
just
kayak bola.
more on the
Kayak rendang gitu. Banyak dapurnya.
how that you want to eliminate
Iya,
that if something happens,
Oke.
for example,
Ini ini.
to make
Kalau
sure
bisa
that
pas
the
masih
car
diem.
runs
Nanti
smoothly and
ada
stop
bawang.
at the
Ini dapat
specific
tambah.
time.
Kalau lebih
Okay.
berarti
Our team already tried to fix everything in our car. We have so much do the run in Kalimantan, and tomorrow there's enough time I think for us for everything to test run before the real race. Okay.
And by looking at your curve, it's not a linear curve. Yeah? It's a higher order non-linear curve. So how you want to make sure that, how do you relate that with, I'm not sure that you can generalize that because it's non-linear. Right?
Polynomial.
Yeah, it's a high order polynomial. So, because on the previous, in the morning session, I never seen this kind of curve. It's a linear curve.
Yeah.
But suddenly we come up with that, and the R square is perfect. So how come the R square is perfect? It's equal to 1. Any explanation of that? Why that you can get the non-linear, the polynomial, because this is the stopping is very important. Remember, the stopping is very important.
Yeah.
If you cannot, if you have a wrong calculation of your stopping, okay, the amount that you need to use, then it won't stop at the desired number.
So actually we already trial and error it to the some line has like that, and it's just like a constant stopping reaction. I think maybe because of the condition too, but after the last time we try to trial and error it, maybe I believe that it will stop at the right time and at the right line too.
Hopefully then. Because we need to have something which is simple, which is linear, but you come up with a non-linear. So if you have linear, then easy for us to calculate. Just find the k, what is the k, and after that, just you know what is the log required, and you can know the distance. Just show it. But you come up with a non-linear, I think it's very difficult to calculate because it's a power of 5, right? Power of 5, power of 6. Alright, maybe you need to have experimentation on that.
Okay, I'm just ask some question for specific reasons, and I just looked at your report here that you use the gravity plate. Where do you put the gravity?
Inside the glass reactor, inside this.
Okay. In your report that you write here is having a flash point at 93 and 0.3 Celsius. It's a very low flash point. I'm just ask one question for that flash point. Do you know about the flash point?
Flash point.
Yes. Apa sih flash point itu?
Nyala.
Nyala.
Untuk reaksi kita modern suhu yang dibutuhkan untuk yang
Terus menerus nggak nyalanya? Oke. Basically adalah secara logisnya begini. In bahasa ya. Pada saat dia mencapai flash point-nya, pernah nggak Anda mengukur pada saat dia beroperasi? Karena kondisinya adalah operation ya, kondisinya adalah operation, dia jalan. Nah, temperaturnya bisa sampai segitu. Padahal itu kalau di bawah itu cukup rendah ya. Misalnya dengan flash point di bawah 100 derajat Celcius itu cukup rendah menurutnya. Berarti dengan temperatur untuk yang graphite plate ya, dia dengan padatan, berarti itu panas sedikit aja itu sudah langsung terbakar, gitu kan? Ya otomatis ini akan mempengaruhi semuanya. Pada saat Anda mengoperasi dengan ini dengan kondisi temperaturnya naik, nah, seperti itu. Pernah nggak dicobakan waktu jalan dengan kecepatan itu tadi, kemudian temperatur di dalamnya naik?
While we test run, the temperature is increased by time, but it's not too high.
Okay.
Yes, it's not.
How much? Temperatur yang bisa dibaca di situ ada berapa? Sampai berapa derajat?
I would like to remind that the
Around
time for
50,
question and
yes,
answer.
okay.
Around 50 degrees maybe.
50 is almost, you know, the increase of temperature itu cepat loh. Kenaikan temperatur itu cepat loh. Kalau itunya dia muter secara mekanik loh. Yakin itu 60 derajat, bisa naik loh dia.
But every we are doing test run, it's not just we're just thinking it's not hot or not high temperature. It's still safe within. No, there's no problem with the yes, but there's no problem.
Di sini belum ada yang sampaikan, jadi memang ada beberapa seperti electrical shock ya. It must be at another control, jadi another apa sih langkah pengendaliannya, kayak seperti itu ya. Itu yang harusnya ada. Yang kedua adalah pada saat itu panas harusnya ada langkah pengendalian. Itu mungkin belum ada.
But we already tried to make the reactor safe from the glass, which is high resistant.
Pada saat temperaturnya naik,
nothing happened with that reactor.
Oke. Kalau misalkan itu naik, apa yang Anda lakukan kira-kira? Pernah kepikiran Anda itu beda? Karena itu potensinya dia panas kan?
Because we never had that situation that over temperature every we do test run, so we're just think
paling panas pernah dicek nggak temperaturnya berapa?
Around 50 to 6, around 50. Yes.
50, 60?
Yeah.
Right.
Okay. Just quick one.
Okay.
The location of water resistance, please make sure that it will not change. And 3 of you already tried the previous one. So, did you analyze what happened during that time? It's not working at all, or there is a problem with the stopping mechanism during the last time? And what did you improve?
In the previous year, we used bubble clock reaction, which is the makes bubble, but it's not working.
This technology is new as well.
Yes,
for you,
yes.
Right. Yeah. So please be sure that you can make sure the car stop properly.
Yeah.
Because the location is not relatively good.
Okay.
Yeah.
Okay, thank you very much.
Okay, we would like to thank for the DevOps team for the presentation. I would like to remind you to go to the inspection table. The inspection table is located beside the registration table, and we wish you best luck and wish all the best for tomorrow's race.
Thank you for attention.
Yeah.
Okay.
The next team will be the team of Wibisana from Universitas Brawijaya. They will be presenting soon.
Put your back down. Alright.
So welcome to this room. Before we start, I would like to introduce you all to our judges. From the left, there's Mr. Komarudin from UTM, and Dr. Elin and Dr. Hari. The given time of the presentation will be 7 minutes and 8 minutes for question and answer. Are you ready to begin your presentation? To the judges, can we start the presentation? Okay.
To all of the honorable judges of ICECC 2018 and all of the committees, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. We are from
Wibisana.
We came pick out from the Brawijaya University. Our team member consists of me, Rizky Abunata Utama, as the team leader, and I'm working on the power source department, and there are Aditya Wicaksana from mechanical department, Hidayat Mustafida from stopping mechanism department, and last but not least, there are Lalu Arya and Muhammad Alodin from electrical department. So here it is. we will begin our presentation to describe Renaissance camping car. We'll be glad to our presentation.
Point to the left.
Diarahkan ke laptopnya, ya, karena sensornya di sana. Nah,
Yang atas itu buat
Yeah, first of all, we'll explain about our car concept mechanism. Our car is powered by voltaic cell. We use voltaic cell because it is cheap and easy to get, and we power our voltaic cell with aluminum and zinc as the cathode, and the mixture of copper sulfate and manganese sulfate solution as the electrolyte. And our car stopping mechanism is using
tadi
iron block.
dibilangnya kalau nggak
Next,
baca
we
tulisan
move to car design and unit feature.
Nanti
As you can see there, our car is so compact and simple with fully easily to assemble and deassemble. And as you can see, the front wheel is easily to adjust for adjusting our car to move straight in line.
And then this is the mechanism of our car from start until it stop. In the right side, you can see the first we put the zinc and aluminum plate in the cell, and then we inject the mixture of manganese sulfate and copper sulfate with 1 molar concentration. And for the stopping, we inject the sodium thiosulfate, potassium iodide, and starch, and the variable of hydrogen peroxide and hydrogen chloride. And then we turn on the LED light, and the motor will be moving. And when the iodine clock produces the red color, the LDR detects the minimum light, and the car will be stopped on the distance limit.
Okay. This is the details of our power source of our car. The electrode is using aluminum and zinc. We use aluminum and zinc because it's cheap. Okay. The electrolytes, we use copper sulfate and manganese sulfate mixture each 1 molar, and the chemical reaction, as you can see, the aluminum is as the reductor and zinc as the oxidator. The cell arrangement, we use 14 cells in series to produce approximately 12.6 volt, which each single cell produce 0.9 volt, and to produce more ampere, we use two 14 cells arranged in series. We arrange it in parallel to produce approximately 900 milliamperes.
And for the stopping mechanism, we use two solutions. For the first solution is the mixture of potassium iodide, sodium sulfate, and starch. And the second solution is the mixture of hydrogen chloride and hydrogen peroxide, which is we put it on different composition based on the distance we need. And in the chemical reaction, we can see that it will form the iodine that we can see on the black color, and it will stop the motor.
Okay. This is the common safety aspect that is hazard in our design. We will explain about 5 common hazards. There is fire and explosion. Fire and explosion, we have known fire and explosion hazard. Sharp object, we have zinc and aluminum as our electrode. Corrosive material, the hydrogen peroxide and chloride as our stopping mechanism. The rotating part reveals movement, but it isn't necessary to notice because it is just a small part. Then the last is irritant material. There is the mixture of copper sulfate and manganese sulfate as our power source. We handle all of this hazard with the proper PPE, that is glove, mask, gloves, and laboratory cover.
And for the economical aspect, we have for the production cost, we spend 475,000 rupiah for the main chassis, for the cell and the electrical component. And for operating transport, it's up to 100 meters. We spend 5,750 rupiah. It's for the electrolyte, electrode, and the stopping solution. And the last is for the environmental aspect. We can see it on material safety data sheet. We will not use the chemical with NFPA greater than 2 except the hydrogen chloride because, but it's not a problem because we don't use the hydrogen chloride on the pure solution. We just use it 1% in Wibisana.
Okay, that's all of our presentation. Thank you. And any questions?
Okay, for the question and answer, there will be 8 minutes. The judges may ask the question.
Okay, then you have 8 minutes to ask your question. Right? Can start?
Okay. Problem with the ground clearance, please be aware because the floor itself is not really smooth, so there will be a lot of bump. Please make sure you can handle that, otherwise it will stop. The second one is related with the photoresistant sensor. Where did you put it? Inside the black box,
Yes.
so there will be no issue in the ambient light.
Yes.
Okay, and the last one is related with your electrical power. Please be aware that aluminum itself, you use plate aluminum or aluminum foil.
Plate aluminum.
Plate aluminum. It will oxidize relatively easy. So if you prepare too long, I'm afraid there will be an oxide layer. So please be aware. Otherwise, your power will be less than 900 milliampere for 12 volt.
Yes, we are already calculated, and the fresh one of the voltaic cell, this voltaic cell will remain until approximately maybe 2 minutes.
Yeah, 2 minutes is a short time. So please be aware about that.
2 minutes?
Around 5 until 7 minutes.
But still, it's also short time.
It will be
Before the oxide layer occurs, right?
right.
Okay, I'm just asked why you use 3 wheels, only 3.
Yes, only two.
What the reasons for use these 3 wheels? And then my second question is, you use there's a hazard from hydrochloric acids, you know? What is the hazard? Corrosive.
Yes, correct.
It's a very corrosive. So I want to know that how you can handle all the corrosive agents during the process, because it's a very, you know, it's not cannot be neglected, but because it's always be considered because it's very effective with the process during the operation with, when the cars was running.
The first question.
Yes?
I'll answer the first question. Why we use three
Wheels.
wheels? Because with 3 wheels we can more easy to adjust the car movement to move in straight line, and it more looks like compact and yeah.
Okay. Okay, second question.
The second question,
How you handle?
how we can handle, we use the proper PPE equipment and
No.
For the material.
For the material during the process, while the car was running, you know,
we use
more process.
we use really bit of concentration for the hydrogen chloride. It's just 1% of the hydrogen
registration table after this. And we wish you all the best and good luck for tomorrow's race.
Thank you.
For the next team, there will be the team of Super Hit team from Universitas Ahmad Dahlan Yogyakarta. They will be presenting soon. Okay, so for the team of Super Hit team, we would like to introduce you to our judges. From the left, Mr. Komarudin from UTM. The second, Dr. Ellen. And the third one is Dr. Hari. For the Super Hit team, are you ready to begin your presentation? The judges, are we good to go?
Yeah.
Cyber on. Super victim.
Is it different one? Wait. So you electronic 15, this is Sandrani. You don't have it?
No,
You don't have this cyber
Is this a super hit or cyber on?
Yes.
Cyber on. It's
Cyber
true.
Ah, okay. Electronic.
Cyber on. Yeah.
Okay.
Super hit. Oh, nama timnya super hit.
Super Hit.
Ya,
Oke.
mobilnya namanya
Cyber. Okay.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good morning, judges and ladies and gentlemen.
Gak apa-apa, semangat ya kita keluar.
I'm sorry. We are
Super Hit
for Department of Chemical Engineering, Universitas Ahmad Dahlan Yogyakarta. First, let us introduce our team. As advisor is Dr. Zarul Mufrodi, as manager is Faris Alauzi, and team leader is Widi Aditya. And our member are N. Eko Yunianto, Adi Gilang, Amaratul Ailia, and the last one is and then this is our card. Our card's name is Cyber O. Let me introduce all of you our card. Cyber O is in front of our card is iron. There is an iron clock, and then beside the iron clock there is a photodiode. Photodiode and iron clock as a stopping mechanism, and then beside the photodiode and iron clock there are a container. In the container, this is our power, and container consists of two hot sink and two cold sink. And then between the hot sink and cold sink, there are two peltier on there. And then total amount of peltier that we use on car is 6 peltier. And then in this section, there is a Arduino microcontroller. And then under the Arduino microcontroller, there is a driver or circuit. And bottom to base of our car is a motor. There is powered 6 volt. And then our car have a unique feature. The unique feature are first, isolate casing for electronic component. It means that electronic component on our car safe from chemical, spill, and fire. And second, chemical for power are dangerous. And third, cheap contraction material. And fourth, damping solution as a hot reaction. Damping is usually called limestone. And this is the first card that using damping solution as a power and the flat, light, and strong construction material. And then for power source, we use thermoelectric cooler. And thermoelectric cooler is mean that peltier. On peltier, there are two reactions. The reactions are hot and cold. On the hot reaction, we can see on the screen here. The reaction will be increase the temperature up to 102 until 125 degree of Celsius. And then for the cold reaction, we can see on the screen the reaction. We mix the dry ice and the ethanol as a cold reaction and will be decrease the temperature up to minus 72 degree of Celsius. And then the differences of temperature is make the power of on our car. And then for stopping mechanism, we use iodine clock. The main of the reaction in iodine clock is a reduction oxidation reaction between the ion thiosulfate and then iodium. And then the reaction oxidation reduction reaction will produce free iodium, and then free iodium will react with starch, and then will be produce the black color from complex starch-free iodine. And then the solution, the clean solution will be turned to the black solution, so the photodiode can detect the light, so our car will be stopped.
Okay, next, this is our brain car, the Arduino. Arduino works as a controller of our components such as a motor, photodiode, and power source. Besides being a controller, Arduino also to drive the motor. As you can see on the screen, this is the picture on the left side is our circuit of Arduino, and the picture on the right side is our program. Okay, next. The algorithm, starting from initialization, where you can determine the pin motor, pin sensor, and sensor limit. The input data sensor is read by photodiode and translated into values by Arduino. When the input data sensor less than or equals to sensor limit, the motor will still run, and vice versa, if the data sensor above the sensor limit, the motor will stop. Okay, next, this is our strategies to reach the goals. We use trial and error and get the data, then create the curve or graph. The most important to get the data, first we should find the mass of sodium sulfate and sodium thiosulfate, sorry, to get the time that can change the color at the right time, or the black color, I mean. And then we should set the limit on the sensor so the motor will be stopped at the right time. This is our in terms of our economical aspects. As you can see on the screen, our construction is just about $10, and the total cost is $48 and $63. This is our safety aspect. The first component of iodine clock can irritate the skin, so we should use proper TPA. And second, we can making sulfuric acid solution. It means that we should add it slowly to prevent thermal shock. Third, our circuit component are supposed to prevent chemical contact. The last one is low voltage and current levels are used in powering, so it can be prevent electrical shock. From all of our components, only sulfuric acid that have the NFP rating above 2. So only sulfuric acid that must be considered. The aspect is environmental. The power source that we use are abundant in nature. There are carbon dioxide and camping or limestone. Then camping is easily recycled, emission-free power source, and reaction of iodine don't produce any hazardous. Okay, this is our presentation. Thank you for attention. Assalamualaikum warahmatullahi wabarakatuh.
Okay, for the judges, there will be 8 minutes for the question and answer.
Kita salam berjamaah in the answer possible. Alright, saya Oka with the super heat team. Alright, that's why I know the reason why the problem is super heat. Yeah, you use that kind of material to get in. And also you have an extreme hot and also you have an extreme cold temperature. So the TC and TH is very big value, and the delta T is almost 200, right? Alright, the question is, why that you need to have that much delta T, the difference in the temperature for your small car?
Okay, thank you for your question. Actually, the temperature are just hanya reach to, maksudnya the maximum temperature, but actually on the practical, the hot temperature just about 80 until 95.
How about the cold one?
And the cold one,
We call this one.
the coldest one, the dry ice mixed with ethanol.
So it's
Minus? No?
Yeah, minus.
Minus 92, right?
because tomorrow
Minus 72.
Minus 72. It's a very large, delta. Itu selisihnya besar sekali. Bagaimana?
is this in on theory, but on practice we measure with the thermometer.
Yeah, again, my question is, do you need to have that kind of temperature difference as that much for your car?
Because the mechanism of PET, yeah,
Mhm.
we need to get more delta on enhanced temperature, so will be increase the volta that we get on the scan. So the car will be run very high, very
High
speed.
High speed?
Yes.
So you have, yeah, for example, if the normal operation is 92, let's say, 92, and you have the dry ice plus the ethanol will become minus 70, for example. That is almost very big difference. Yeah. Can you just only use dry ice or just simple ice?
Yes. Actually, when we use ice water,
Yeah.
this car can run.
Yeah.
But because our ICECC, we write the dry ice. So and this rest we use this as dry ice too. Actually, before we write make the GSA, we don't try using dry ice.
You use
Because,
the water ice.
yes.
You use the water ice.
Because
And still it can move, right?
yes, but not too long the time.
And this is not for the long, this is not for the distance.
Yes.
This is not for the long distance, it's just for few meters, right?
Yes.
Yeah, because if you have a dry ice plus the ethanol, you need to also have a safety in order for you to handle it. It's not like you just handle water ice. Right? Because it's very, very, very cold.
Frostbite.
Frostbite, maybe.
Yeah.
Yeah, this is very minus, it can be hurt in your hand or any
We
tools.
use clip
Yeah.
With ice.
to take the
Device,
dry ice
yeah.
to take dry ice to be protected.
Right? She's the safety expert.
Okay, thank you, sir. But I always say that I always see that your mention list for potential hazard in your sequence of steps process about you write this about the exposure to alcohol vapors. How many percentage of exposure? Because you know that yourself, if you read in this NACS, ya, di situ kalau alkohol itu sangat apa? Toxic, ya kan? Yeah. It's a very dangerous, very dangerous and hazardous material, including the hazardous material. So, what do you do to eliminate the hazard, to control and eliminate the hazard? Because your only way this area will be ventilated. So if you indoor like this, how come?
The ethanol is for the cold seat.
your fan near the car?
No, but ada celahnya. Jadi terus juga the ethanol that we use just small amount, only 24 milliliter.
And then, well, while this is operating, this is while this is operating, so there's a very different temperature here about this camping out there. Nah, itu tadi makanya kalau di sebelahnya dia panas terus kemudian tiba-tiba dingin seperti itu. Kira-kira kalau menurut Anda sudah pernah nggak dilakukan identifikasi apa yang terjadi pada saat si kulit itu bisa berjalan?
Maksudnya
Dari sequence ini karena dia mau ini kan ada proses ini ya, dia diproses di runtime prosedur di sini Anda menyebutkan itu ada exposure lagi gitu. Kan berarti ada di setiap itu ada exposure terus. Jadi kan exposure itu terus-terusan dia mengeluarkan ya kan? Meskipun itu dalam small amount. Lalu apa yang Anda lakukan? Hanya membuat ventilasi terus-terusan? Tidak ramah lingkungan ya?
I think the camping is not dangerous.
Yeah, camping is not dangerous. But the ethanol.
The ethanol is for semua just little. Kita masukin cuma dikit. Jadi when kita tutup, kemudian misalnya kita udah berhenti dengan itu, nanti kan kita ambil lagi etanolnya, kita recycle buat hidupnya exposure yang
Etanol bisa recycle lagi. Dia menguap loh, cepet loh.
Nah, setelah kami
Ini prosesnya dia running nih.
Yes, but we trial tomorrow. We trial tiga kali running. The menguapnya nggak banyak, jadi masih tetap banyak segitu aja.
Okay.
Yes,
We
yes,
try.
we try. We practice once more. Yesterday.
Yesterday.
I'd like to remind that.
Yeah,
You mentioned.
quick question.
Okay.
You have a small component under your car. What is the purpose of it? Because it seems the ground clearance is too low. I'm afraid it will stuck into something. Okay. The second question is related with the impurities or gumping itself. If you use pure calcium carbonate, it will be okay. But when you use gumping, it will contain magnesium oxide, silica, and etc. What would be an issue if you use the real gumping? You will use the real gumping or
Yes.
you use calcium carbonate?
The
Real gumping, and it will be different from side to side.
Iya. Beda loh sama kalsium karbonat.
Yes, we practice both. Jadi
Okay.
kita and then we compare the exothermic reaction both CaCO3 and gumping solution. We have hasil yang berbeda. Jadi CaCO3 itu panasnya lebih dapatin panasnya dari proses electrolysis-nya lebih lama daripada gamping. Gamping is fast to get hot reaction. To increase the temperature is so fast, but CaCO3 is agak lebih lambat daripada gamping.
Tapi durasinya lebih lama yang gamping
Yes.
atau yang kalsium karbonat?
Gamping.
Durasinya juga.
Yes, we practice 109 degree of Celsius is bertahan sampai 8 menit.
8 minutes. While for calcium carbonate,
Yes.
that one is not
Calcium
gamping.
carbonate.
Kalau pakai kalsium karbonat kita tidak mengukur soalnya sangat lama panasnya, jadi kita langsung buang, jadi tidak ukur yang
Yeah, but once you reach the certain temperature, it will last longer if you use calcium carbonate. So please be careful. And how about the answer for that small component
Just
under?
what is that?
Nah,
And this is the acrylic to
Okay.
make.
Is it possible to stop
Yes.
if you have something at the bottom
stuck.
of it?
It can be stuck.
Uh,
If there is a small bump,
I think that will be stuck.
yeah.
But
No,
How?
stuck.
ya,
Yeah, it's
kalau
possible.
ada ganjil.
Yeah.
Ya, bisa ganjel itu dia nanti bisa.
Yeah. So how can you manage it?
Increase the
You ground clearance, right? Yeah. So please make sure you try it. For tomorrow.
Change the wheel.
Iya, change the wheel.
Okay, thank you.
Alright. Thank you judges for the questions. We would like to remind to the Sparky team to go to the inspection table after this. The inspection table is located beside the inspection table. And we wish you all the best and good luck for tomorrow's race. The next team will be the Spectronics 15 from Institute Technology School November. They'll be presenting soon.
50.
Yes.
15 and
Don't worry. Okay, thank you very much. Who will be the next MC?
Where are you going?
Please.
Thank you.
Go.
Atlas.
So who will be the next MC?
Next
You will be
MC.
the next MC? Okay.
More
Otherwise,
fresh. Iya,
Profesor Komarudin
akhirnya
ya.
lebih fresh. Akhirnya ketemu MC yang wanita. Tadi MC-nya cowok.
Okay, good afternoon. My name is
Bisa
Sandy.
dibuka.
I will be the next MC.
Bukan PPT guys.
For the next, we have the Spectronic
PPT itu. Tapi sebenarnya bisa dibuka.
15.
Tontonan di Instagram. Tadi bukannya kan harus pernah buka PPT kita. Tadi bukannya kan buka. Itu harus buka. Yuk.
Welcome to the Spectronic team. You will have 7 minutes for the poster presentation and 8 minutes for the Q&A session. The time will be shown on the screen behind you. So please, you won't block the screen. You may start the presentation.
Di mejanya mas, di meja. Iya.
The pointed.
Oh, pointed.
Di area.
No, it's not working.
Coba. Ya, udah.
Okay, it's working. Yeah.
Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
For years and years, we can see in newspaper, television, and demonstration. When talking about energy, we're just talking about fossil fuel, especially the price. While actually there are several sources in Indonesia that we can apply in commercial car. Honorable judges, hear us. Institute Technology 10 November proudly present Spectronics 15.
Creating
More innovation,
for the next
generation. Okay, this is our car that named Spectronics 15. It's an electrochemical car powered by aluminum air battery in stack configuration and using degradation of magnesium as stopping mechanism. Okay, almost all of the part of this car are made by which is light, strong, and not react with chemical use. For the design of this car, we inspired by aerodynamic of Formula 1 to give best accuracy, best precision, and best performance. Okay, for the overall system of this car, first, the upper power from the battery will flow into voltage regulator that has function to stabilize the voltage. Like this this line will be this line for the output power. And then this constant power will flow into stopping mechanism and motor. The motor will move the gear set that is connected to axle of the wheel and the car will move. For the stopping mechanism, this car will stop when
magnesium has fully corroded or fully degraded by hydrochloric acid solution. For the uniqueness and the detail of power source and stopping mechanism will explained by my friend.
So, the power source, that our car is powered by the aluminum air battery that is constructed in stack configurations. Our car uses 15 cells in series parallel to achieve the desired power. In theoretical, the voltage of the aluminum battery produces 2.5 volt, and it reduced in our battery it reduced to 1.5 volt. So the component of our battery is the aluminum plate that is coated with the petroleum jelly as inhibitor, and the filter paper also coated with 2 molar sodium hydroxide and the mixture of the carbon and the manganese dioxide, and the cover plate to connect the current flow, and a pair of acrylic plate with 4 sets of bolts and nuts to tighten cells together. So our battery have several uniqueness. First, there are several components that are fully reusable, such as the aluminum plate and the copper plate. And the use of cotton will reduce the use of electrolyte and prevent any spill from the battery. And the really interesting is the fact that our battery is really stable, up to 250 meters.
Okay, for the stopping mechanism, this car will stop by using the degradation of magnesium. Certainly, this system works by disconnecting the electricity. So the electricity keep through magnesium by the strip connector. Then, to break the magnesium, there are oxidation reaction by hydrochloric acid. So it will disconnect the electricity when magnesium is fully degraded. This reaction takes place spontaneously and does not affected by surrounding conditions, such as temperature and pressure. As the product, there are a little amount of hydrogen gas produced, so it will not give a meaningful effect to the environment. As a result, the system gives accurate time duration that determined by hydrochloric acid concentration. So, the system support by roll clamp that give constant droplet flow to give accurate daytime duration with the same concentration of hydrochloric acid.
Although with more innovation, we also see environmental and safety aspect. There are several conditions that make our car safe. First, aluminum air battery doesn't contain mercury or other hazardous elements such as cadmium that are commonly used in ordinary batteries. And second, secondary container is used to make stopping mechanism more safety. And then, almost all chemicals in our power source are usable. And the last, manganese dioxide is used to absorb hydrogen gas. So there will be no hydrogen gas that will appear in the air. And the last, the 4 personal protective equipment is lab coats, safety gloves, masks, goggles, and safety shoes.
Full of innovations, Spectronic 15 has 5 unique features. First, use of worm gear will reduce its stopping distance. Second, wide tire will improve its grip to the surface. Third, accurate stopping mechanism. Fourth, the amount of electrolyte used in Spectronic 15 cell is less than ordinary wet cell batteries. And the last one is constant velocity thanks to the voltage regulator. So it is easier for us to determine our stopping time. For the economical aspect, we spend that much for the investment cost. But for operational, we spend 2,250 rupiah for 25 meter operation. But actually, for one set of battery, we could use it for up to 250 meters. The aluminum air battery used in Spectronic 15 car have high potential to be used in commercial car. But to achieve our dream, we need a lot of research and also a lot of support from the government and other elements. Thank you so very much for your attention. We have for Spectronic 15.
Creating more innovation for the next generation.
Do you have any question?
Yes,
Of course.
Yeah, thank you for the Nashid team. Okay, we can ask.
Okay, Mr. Hari.
Okay.
First one, you mentioned that you can use all of the electrolyte, but don't you think aluminum will oxidize as well? So if it is oxidized, for sure aluminum eventually will decreasing in terms of the amount. The second one is related with the use of WD-40 as a coating material. You mentioned in the something here in your document.
Yes.
Okay. So don't you think it's also dangerous to the environment for WD-40? And the last one is related with magnesium. We use magnesium in a metal form, right?
Yes.
And it will react very easily with water, even in ambient temperature with high humidity. How to control that point as well as the hydrogen side product?
Okay.
Okay, thank you for your question. I'll answer the first question. That it is still do the aluminum do the reactions of the oxidation with the less electrolyte. So yeah, it is because although we use the electrolyte, but we use the 2 molar of sodium hydroxide. That is also react with the aluminum because we know that aluminum is reactive to the base, and we use the strong base, which is the sodium hydroxide. So it is do oxidize the aluminum.
Okay. So eventually it will okay. Next.
Okay, for the second question, I will answer your question. There are some wrong with our document, but not wrong because when we make this document, first we use WD-40, but now we change this with inhibitor like porcelain jelly in Vaseline. Okay. This competition should make moment of change of document. So in the day we can check this again with and confirm again with the committee.
Okay. That one, magnesium.
Okay, let me answer your question, sir. First, about the magnesium react with water. Our pre-treatment with the magnesium is in the insulated place. And for the car, we can see that our stopping mechanism for the place that magnesium will react with hydrochloric acid is the insulated place.
Okay, so it will not react with the ambient air.
Yeah.
Okay. And the hydrogen side product.
Okay. About the hydrogen gas product, the magnesium used at the low mass, that resulting low amount of hydrogen gas.
How the hydrogen release directly to the environment?
Okay. The hydrogen release is I want to show you. Okay. This is we use some circle and the storing condition for the ventilation of hydrogen gas.
So you're preparing on the venting.
Yes.
Yeah.
Okay. Okay. Thank you.
Saya mau melihat di sini untuk yang prosesnya ini ada yang disebutkan kalau ada flammable. So which process that you identify that the potential hazard of flammable? Yeah. Can you show us the car and finding where the process is like? Bring the car to us and show us.
Very good question. I will answer it for you. So the potential flammability is from the hydrogen itself, and then this car is active car. So when it starts with it could potentially produce spark, and the spark will ignite the hydrogen. That's what we worry about. But we already have way to avoid that problem. First, use of diode will stop the current. The use of diode in the voltage regulator will avoid the short circuit. So it won't produce a spark.
Potential short circuit.
Yeah, but we already make a way so it won't happen in our car. And another one is because before the hydrogen could be released from the stopping and the reaction of the battery. But in the battery part, we already add manganese dioxide. So the manganese dioxide will react with hydrogen to produce manganese oxide, and the hydrogen won't be released into air, so it will stay inside here. And it will react into water, so it will be safe for the environment. Yeah.
So you identify that's the potential hazard.
Yes, and we make a way to avoid the hazard.
Okay.
It's also including how to prepare the magnesium.
Yeah.
Because the magnesium itself, you
yes.
need to put directly. Inside, during the operation it's okay. But
operation is okay.
But how about during startup, during the preparation?
Okay, I will try to answer. Okay, for the preparation of this magnesium, like, preparation or treatment. For the storage of this metal, we use silicone gel for in sealed container. For the before we use in operation, we dissolve it in hydrochloric acid too, but in certain time or 1 second or 2 seconds, but in same with all metal.
Just before you put under.
Yes.
Yes.
Alright. So with the 7 volt, constant 7 volts, how fast that the car can move?
Yeah.
Jangan berebut jawab.
Oh yeah.
That's good.
That's a very nice question. How far? So in this competition, ICECC, we use voltage regulator to stabilize the output power from 7 volt only about 3.3 volt. So for this competition, this car will go for about 0.5 meter per second. But for the next week, for the next competition, we have competition in Malaysia, in Tati University, and it requires high velocity. So when we put the voltage regulator away for the Malaysian competition, it will go for about 0.9 meter per second.
That is at what 7?
What?
What volt?
What?
That's 0.9.
Oh,
without
yeah, still the same power output from the battery.
So you think this one to Malaysia next week?
Yes.
The same car.
Yes. Same power.
Right.
Yeah.
And you have mentioned before that this car will get violent. So usually the spark will happen. So have you ever experienced the car running with the fire?
I would like to remind you that
Right. Okay, last question. Have you ever experienced with the fire?
Yeah. So we never experienced the car is on fire, of course, because we ensure the safety of this car. But it is a potential hazard that hydrogen here could be flammable, or maybe before here produced hydrogen could be flammable. So we put it on the our document, but we ensure that there will be no fire from our car because we already have a certain way to avoid the fire.
Can you cover that thing during the race?
What?
The battery.
Battery, yeah.
Can you cover it during the
during the competition?
Is it possible to cover it?
No, we didn't cover the battery because this battery will produce.
Just make it
close container.
We didn't make that because our battery have didn't give any potential to spill.
Yes, you can easily put it off. That's all.
Yeah.
Once you have settled everything, put the everything and you cover it.
One module cartridge system. So you just take it out direct.
We can
one by one.
Jadi terlalu banyak seperti itu.
Yeah, we can put it like this. So that's it.
Okay, last question.
Yes.
You put that 2,000 instead of using Formula One model. I think it's better to use dump truck model. It will be useful.
Yes, ibu atau nama bis gitu.
Okay.
progress to you tomorrow and next week.
Yeah, thank you very much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Spectronics 15, for the presentation. You may proceed to the inspection table.
Yeah. Terima kasih Metronic. Nasyid. Thank you. Thank you.
You're the one who completed the ICECC.
That is about formulation. Next week we have
Chemical.
The next team is Sumbrani team. They will present soon.
Tujuan gede.
Welcome, Sumbrani team.
Can we check the sound first?
Welcome, Sumbrani team. You will have 7 minutes only for the presentation and 8 minutes for the Q&A session. The judges are Dr. Kamarudin, Dr. Elin, and Dr. Hari. The time will be shown on the screen behind you, so please do not block the screen. So, if you're ready, you can.
Good afternoon, everyone. Okay, the world's population is increased per year, and it means that the need of energy is also increased. In 2015, the consumption of energy reached 575 quadrillion BTU. And 77% of that comes from fossil fuel, which is non-renewable energy. And the need of efficient alternative energy has led all of us here into the invention of chemical.
But recently, the chemical itself has a problem with their own world, which is the crisis of energy efficiency. The use of chemicals is something that must be taught. Therefore, here is a brand
Effective gas car
comes to provide the solution for utilization of chemicals that are more effective and efficient to get more satisfactory result. Okay, my name is Shauki.
My name is Aprilia, and there are Marcel and Habib. We are from Sumberani Universitas Gadjah Mada. Okay, first of all, let us introduce you to our car. Our car is pressurized gas car that gets the energy from hydrogen peroxide decomposition reaction. Here is the cabin design and the unique feature of our car. Our car has dimension 14 times 23 times 30 centimeters. It's built on acrylic acid chassis, and also the wheel is also from acrylic to make it stable to move. Our car has strong materials, non-toxic chemicals, eco-friendly materials, and has high rate of reaction. Okay, here is the outline of the presentation today. First, we will talk about the frame design of our car, and then followed by the vessel design, and then next to the motion system, next to the environmental and subject aspect, and the last one is from economical aspect. Okay, let's get started with the frame design. And as said before, our chassis is built on acrylic with a thickness 8 millimeters. Why we choose acrylic? Because it is easy to be found, resistant toward corrosion, and also light. And here is the scale. It is for water trap, it is for the load, it is the mechanical valve, and it is for the pneumatic. Okay, that's next to the vessel design. Here is the design of our vessel. Here we have 4 holes. One is for the inlet of the hydrogen peroxide. 2 is for the inlet of the catalyst. 3 is for the safety valve. And the last one is for the pressure gas and the outlet of the gas. For the material itself, we use stainless steel S304 because it is light, resistant toward corrosion, and can be found easily. The thickness of our vessel is 1.5 millimeters, with specification is shown on the screen. Okay. Next to the motion system. The reaction of decomposition hydrogen peroxide happens in vessel with catalyst ferrosulfate. Once it decomposes, it will produce oxygen in the form of gas and water in the form of liquid. After the reaction is completely decomposed, we will open the valve so the oxygen gas will move into the water tank. But there will be a little amount of water that carried by the gas, and then will be absorbed in the water tank. So only the oxygen gas will move into the pneumatic, causing a reciprocating motion, and then in the crankshaft it will convert it into the rotational move, and it will move the gears and will move our cars. Okay, next to the environmental and safety aspect will be delivered by Xiaoqi.
Okay, for the environmental and safety aspect, we analyze the hazard of our car using process hazard analysis method. The overall process hazard analysis method divides the hazard into two. The first is hazard material, and the second one is hazard process. For the hazard material, we analyze the hazard of our car, use the diamond hazard. Based on the diamond hazard, the only material that needs a special treatment is hydrogen peroxide. That's why we decrease the concentration of our hydrogen peroxide from 50% to 15% to minimize the hazard material that comes from hydrogen peroxide. And for the second one is hazard process. For the hazard process itself, it's also divided into two. The first is pressure, which our operating pressure is 20 until 40 psi, and for the operating temperature is 70 degrees Celsius. To make sure that our car is safe, we equip our car with safety precaution equipment. That is, the first one is pressure indicator, and the second one is insulator from sponge hati, and the last one is safety valve. Our safety valve is ruptured disc relief device. Next, for the economical aspect, here is our list of reagents to travel the distance of 10 meters. For the first one is hydrogen peroxide, with the price is 220 rupiah, and the second one is ferrosulfate with 680 rupiah. So the total is 900 rupiah. For the last one is our research data. Here is the correlation between the volume of hydrogen peroxide in milliliters compared to the distance that traveled by our car in meters. As we can see from this picture, the correlation between the volume of hydrogen peroxide and the distance is directly proportional. And if we make a linear approximation, we can get the value of R squared is very near to 1. That proves that our linear approximation has a valid data in our research data.
Okay, so I'm sorry. Okay, so for the summary, our car is eco energy, has high efficiency because it is high rate of reaction, and the last one it is strong. Okay, that's all enough from our presentation, and thank you.
We will continue to the Q&A session. You have 8 minutes for the Q&A session.
Alright, thank you Samrani for your presentation. So my simple question is, this is not the new car, right?
What do you mean with not the new car?
New car meaning because you don't show us the cost of develop or fabricate the car.
It is a new car that we built in our team. We didn't insert it on our poster because we think that it will meet it only the operational cost.
CapEx, we also need capital.
You also need to do the
The manufacturing cost. Okay, the manufacturing cost is around 1.6 billion rupiah.
Billion or million?
Billion.
Alright, because yeah, the total is less than 1,000, that's why. Yeah. Okay, that's for the operation.
Okay.
Right, so you have operation. Okay, that's good. And you have high pressure.
Only 20 until 40 psi.
Are you sure it's only?
We
More or
have
less 7 bar.
okay.
Yeah.
We have kind of like presentation like this in our lecture in our home university, and they say that we at the first place we say that 20 to 40 psi is a high pressure, but our lecture said it is not high pressure enough if we say it in chemical engineering, because there will be a
For the
high
planet,
pressure.
for sure, it's not
For
a
sure, it's not.
This is a reactor for moving a car. It's not producing a chemical product.
Okay. Okay, but we equip our vessel with a safety valve. The safety valve can endure the pressure under 146 psi. So if our operating condition only from 20 to 70 psi, I think it's safety enough.
Okay. And you are mentioned here, and also in your report, also here, you have a new catalyst.
Yes.
Alright. So this, what do you mean by new?
Okay. What we mean by new catalyst is this is not catalyst that we build by ourselves, but this catalyst is never be used in other competition. What we mean by the new catalyst
That's
is
why.
that case.
So the new should be declared as never been used before.
Yeah.
In this reaction.
Yes.
Right? Are you sure?
Yes, we service we've checked the list of the car that has.
What basically the catalyst that people use in this kind of reaction?
I'm sorry.
Catalyst, what
This
basically
is
the
peroxide decomposition.
Yes, it's
right?
peroxide decomposition.
What is the normal catalyst?
Whereas the normal catalyst, it can come from perchlorate, and then how to say kalium permanganat, potassium permanganat, and then yeast. Yeast can also be the catalyst of the decomposition reaction.
So how basically the performance of your new catalyst here compared to the common
Can
one?
we show the after slide of our presentation? Yes.
This is a good calculation.
Here is, you can see it is data that we get from the journal that the ferrosulfate has the highest constant rate of reaction among the other catalysts.
Yeah, that is the reaction rate.
Yes.
Have you tried with the different catalysts in your reactor?
We've done compare it, but if we compare to the last of our car project, it is from my senior. They use yeast as a catalyst. The performance of other catalysts is more faster than theirs. Although their catalyst is yeast, it is a biodegradable, something like that.
So your one is not sustainable, not environmental friendly catalyst.
Compared to the yeast, it is less sustainability concern.
The car that you want to build here, or you want to put for the competition here, you want to more on the performance, right?
Yeah.
Rather than environment.
Here I would tell you that we also concern on the sustainability living, because the waste handling of our car, if we have a plan that there is a fly ash that can absorb ferrosulfate and it make it less hazard for the environmental. That's the plan from our team to concern in sustainability.
Since you're talking about the safety and the hazard,
yes,
then we have experts here. Then we over the safety one.
Okay, thank you, Mr. I just want to ask about, I'm just curious about the TESA. Can you show me the calculation for pressure design?
Sorry.
Yes.
No, that is the safety one. Safety factor.
Okay. Safety factor 3. Okay. Have you tried with the design that you made for the vessel? I think it's very good. But it seems to be control for safety control systemnya pakai indikator dan lain sebagainya. Tapi masih ada yang harus dipertimbangkan. Antara lain yaitu pada saat proses di mana
injection catalyst.
Ya, dan satu hal lagi dari penambahan volume, ya. Volume hydrogen peroxide. It's more volume hydrogen peroxide, so that the more velocity. If the more velocity, so this pressure is more
higher.
Nah. So what do you do if there's happening with this car?
What do you mean by that is happening? What will happen next?
Yes.
I mean,
you must think about that because you use the vessel. Okay, they have potential hazard.
Yes.
Is,
To explode?
Not explode. They're very extreme. The very the first potential hazard will come if we have the vessel is about the leak.
Yes.
And then maybe you cannot use your pressure indicator. Yeah, it can be broken. Yes. It comes first.
Okay.
Before it's blow up. You don't be extreme to blow up because that's what I know. Tadi karena perhitungan Anda dengan pertambahan volume, ya, pernahkah Anda uji coba dengan pertambahan volume dari grafik tadi? Karena saya melihat bertambah volume, dia bertambah velocity, bertambah naik.
Yes.
Yeah.
But we consider it at the first place that our vessel can enter the target of this conversion 25 meters, and we have done a calculating using a gas ideal that the pressure that will be produced is only the maximum is 70 psi.
70 psi.
And 70 psi. And
So you have been tested before?
Our vessel has been tested in 100 psi.
100 psi.
Yes, and it is
Not,
safe.
Hydro test.
Hydro test.
Yes, hydro test.
Oh, okay, hydro test.
I would like to remind you that the time is over.
Quick question. You mentioned that you use safety relief system using rupture disc, right? Based on your picture there, it seems like
for the
safety valve,
okay.
not the rupture one, not the rupture disc.
Not the rupture.
It's totally different because it can pop on, pop off. in this case. Rupture
Also,
disc
there is a disc here, so that it explode when the pressure is exceed the limit.
Yeah.
Okay. So
Because you use spring there. That's not gas.
okay, I'm sorry. So the limit is spring relief device.
Yeah.
Okay, thank
And
you
the
for
second one is related with what is the total weight? Please consider about the momentum when you try to stop it, particularly at relatively higher pressure.
Do you have a braking system?
Yeah.
Braking
I don't
system?
think there.
No, we didn't have it.
Only based on the oxygen,
Yes,
right?
when the oxygen test is run out, our car will stop.
Yeah, so if there is, you will have momentum, particularly if the runway is not flat.
Yes, this does flat.
Yeah. Thank you.
Thank you for the question and the comment.
Thank you, Sumraniti, for the presentation. You may proceed to the inspection table.
Okay. Thank you, sir. Thank you. Thank you.
The final page. Coffee break, right?
Yes.
There will be a break for
Team technician.
and we will continue at 15:20.
Okay. Will you take this one?
Just leave it there.
Okay.
Apa? Basement Pak. Di bawah.
Ini ya, nggak penting tuh ini.
Tapi kan ya masa ya kelihatan kan kalau misalnya.
Nggak iso.
Iya di break diputar lagu aja, diputar video sponsor.
Pusat.
Sorry. Kalian ada berapa? Bawa kepiting Pak.
karya-karya monumental bangsa. Kami adalah bagian dari keseluruhan negeri yang senantiasa menjaga nilai setiap tradisi di dalam kualitas yang kami pertahankan bersama dengan identitas negeri demi sebuah kebanggaan yang tidak akan pernah dilupakan oleh zaman.
63 tahun umur PP adalah umur yang cukup panjang dan dewasa dalam mengelola sebuah Pelabuhan Kali Baru adalah kebanggaan baru bagi PP. Pada era sekarang kita punya deck on pile seluas 40 hektar. Di upstream kita akan dapat return dari investasi. Di middle stream pada saat konstruksi dan EPC bergerak. Di downstream kita punya high-rise trigger dan equipment. Sehingga semua pemegang saham akan dapat 3-point swing effect dari seluruh proses bisnis PP. Pada ujungnya PP akan menjadi terbesar di Asia Tenggara dengan market kapitalisasi target pada 2 tahun ke depan sebesar 120 triliun.
Sejak berdiri PT PP sebagai Green Construction terus fokus menjalankan bisnisnya dengan berorientasi pada pertumbuhan laba, profit, pengembangan SDM, dan kepedulian lingkungan, pelayanan. Menjadi sebuah kebanggaan bagi kami, PT PP Persero Tbk menjadi pionir pembangunan konstruksi di Indonesia. Didukung oleh pilar-pilar bisnis utama yang diklasifikasikan menjadi upstream, PP Property,
Bank Mandiri, BNI,